P of n is there. P of n also have some formula. What is the formula? Equation 2 saying P of n formula. Okay, equation 2. So P of n is equal to this formula, and this formula is substituted in this equation. Where P of n is there, you simply substitute this value into z power of minus n by d into z power of minus n by d is there. Okay, so after simplify this equation, what we are getting? So this term I am taking forward, and these two terms also, these two terms are taking, and these two terms are inserting this one. Okay, after simplifying this equation, y of z is equal to 1 by d summation k equal 0 to d minus 1 x into e power of minus 2 pi k by d into e power of 1 by d. Okay, and this is equation 7. Substituting z is equal to e power of j omega, that is in frequency. Okay, wherever z, you simply substitute e power of j omega, but here z is there, so in place of z you simply e power of j omega, e power of j omega. So you write similar manner. So here also z is there, in place of z e power of j omega, that is equal to 1 by d summation k equal 0 to d minus 1 x of e power of minus j 2 pi k by d into e power of z means e power of j omega, e power of j omega by means e power of j omega by d. Okay, in this bases are same, so powers are added. Okay, powers are added. Simply we are getting y of e power of j omega is equal to 1 by d summation k equal 0 to d minus 1 x into e power of j omega minus 2 pi k by d. This is considered as the equation. This is the final expression for this one, spectrum of the downsampled signal. This is very important topic in 5th unit. Okay, and next to go for, and this is the, just you observe what's going on here. Okay, and this is the spectrum of input, that is then a modulus of x of e power j omega. Okay, this is the spectrum. Spectrum means frequency. Spectrum of input sequence, that means x of e power j omega band limited to, I mean omega is equal to pi by d. Okay, and this should be considered as a spectrum of input. Okay, and this is, should be considered as a spectrum of output. Okay, but here no inputs are there, but here the output is get, that is the output. Spectrum of downsampled, why we are discussing about decimation only. Okay, the spectrum of downsampled signal y of e power j omega is some of the uniformly shifted and stretched version of the x of e power of j omega scaled by a factor 1 by d. Okay, 1 by d, that means pi by d, 2 pi by d, 3 pi by d, 4 pi by d, 6 pi by d, 2 pi by d, but here 2 pi is not there. Why? Factor already 1 by d. So this is regarding spectrum of output. Okay, this is actually, it's a normalized, this is the spectrum of normalized output. Actually this is the final output, but this is the normalized. Okay, actually this is enough. From this input signal, this is enough, but here also I am writing this is the normalized, that means average normalized output, spectrum of the normalized output. Okay, next very important topic is the aliasing effect or anti-aliasing filter. Just you observe, we can find that the spectrum obtained after downsampling will overlap if the original spectrum is not band limited to omega is equal to pi by d. The point saying here only, overlap means one signal is overlap with another signal. That is like, for example, this is a signal and this is another signal. So one signal is overlap with another signal, that is like this. I am showing graph particularly, showing in a graph. Okay, actually this is the input spectrum, that means input signal. Okay, input signal is overlap with the another input signal, like this. Okay, this is wherever the overlap symbols are there, this overlap symbols are known as aliasing effect. Okay, this is aliasing effect. This is the input spectrum and this is the closed output spectrum. That means aliasing, sampled aliasing. Okay, actually these signals, these two spectrums are overlapped here. That overlap is known as aliasing effect. Okay, this totally diagram is known as frequency spectrum of downsampled signal with overlapping. Okay, The signal obtained after filtering is given by v of n is equal to summation k equal minus infinite to infinite h of k x of n minus k and y of n. That's the downsampled signal y of n is equal to